In this video, we want to find the values of a function given the graph of its derivative and some initial value. So to do this, we want to use the fundamental theorem of calculus. Remember, the fundamental theorem of calculus says the following. If I take the integral from a to b of f prime of t dt, that's equal to the value of the function f at b minus the value of the function at a. So what we're going to use here is the fact that this is the area under the graph of the derivative, f prime of t. So we're going to be given the graph of f prime of t, graph of the derivative. We're going to be given some initial value, that'll be f of a, and then the unknown will be f of b. That's the value we want to find. So we'll know f of a, we'll know the graph, so we'll know how to compute area, and then we'll find f of b. So let's look at an example. Here's a nice graph. So here's the graph of a function. But the graph that we're looking at, this is going to be a derivative. The graph of the derivative, not the graph of the original function, but the graph of the derivative. So we're going to compute the integral of this. So we want to compute f prime of t dt. And suppose we want to do it over the interval between 0 and 3. So what's that? That's the area under curve between 0 and 3. So what is this area? Well, this is given by a triangle, so we can use the area of the triangle formula. Is equal to 1/2 base times height. And here the height looks to be 2. That's our height, 1, 2. And the base is 3. So 1/2 base is 3. The height is 2. Altogether, this is just 3. So this has area 3. Now, that means that the integral is equal to 3. So what does the fundamental theorem of calculus tell us? It tells us that 3 is equal to f of b, well, b is 3, so f of 3 minus f of 0. So 3 is this. Now if I'm given this initial value, suppose the initial value is equal to 4, then this says that 3 is equal to f of 3 minus 4. In other words, f of 3, by adding 4 to both sides, is equal to 3 plus 4, which is 7. So by knowing the value, the initial value, what happened at 0, plus knowing what this area is, I can figure out what the value of the function is at 3. Let's do another example with the same function, that is, given its derivative and given its initial value to be 4, that is, I'm assuming f of 0 is equal to 4. Let's do a different example. In particular, maybe I want to find out not what the value is at 3, f of 3, I want to find out what f of 2 is. Still, my derivative, its graph looks like this. I want to find the value at 2. Well, here I found the value at 3, so I took the integral all the way to 3. Now I want to stop at 2. So I should take the integral from just 0 to 2. Now the integral from 0 to 2 of the derivative is the area under the curve is given by f prime, between 0 and 2. So now I'm only talking about an area up until 2, just this area. Well, it's still a triangle, but it's no longer has the same base. So the base is now only 2. So 1/2 times 2. Now the height is still 2. So I get 1/2 times 2 times 2. So the new area, the area of this triangle, is only 2. So that says that the integral is only 2. By the fundamental theorem of calculus, that means that the integral, this, is equal to f of 2 minus f of 0. Okay, everything changes to 2. No longer do I have a t value of 3, but I have a t value of 2. Assuming that the value, again, of f of 0 is equal to 4, this says that 2 is equal to f of 2 minus 4. Now, I add 4 to both sides. I get 6, and I get f of 2. So the value of the function at 2 is 6. The value of its derivative is 2. The value of the original function is only 6.